So real quick, we're just going to talk about how you use cylindrical and spherical coordinates. This step should feel really familiar to you from when we learned how to use polar coordinates. So the first part, and maybe the hardest, is identifying which coordinate system is best. Rule of thumb, spherical is going to be easier when you have spheres, but not much else. Cylindrical is going to work for anything that involves circles. And that sounds kind of specific, but that's going to involve cone shapes, paraboloid shapes, anything where you see like an x squared plus y squared, circle-ish, and a lot of shapes that we've worked with tend to be this way. But you want to still have like Z is not a circular shape, because if Z was circular as well, then you'd be thinking about spheres. Spherical is easier. And then you're going to want to sketch your region of integration. The reason for that is because it is very hard to puzzle out from a formula in X, Y, and Z what your, for example, phi should be unless you draw a picture. And that's going to help you do the next step, identify bounds and new coordinates. So for cylindrical, you're going to need r between some bounds, theta between some bounds, but z is going to stay the same. And then for spherical, you're going to need all new bounds across the board. Your rho is going to fall between some values. Your theta is going to fall between some values. And so is your phi. And then you just convert all your variables to new coordinates using these two like lists that we came up with that I want you to have handy in your notes all the time because you'll need them. Just a couple warnings. Don't forget dv. Or xy values in z bounds. So don't forget dv in general, but then since your z bounds stay the same, they could have depended on x and y. Don't forget to change those. Hopefully you would notice once you start moving through the problem that there's x's and y's, you don't integrate with respect to them, but still just be careful. And then same as you would have noticed with polar coordinates, this x squared plus y squared and this x squared plus y squared plus z squared replacement are going to be easier than the ones that involve trig functions. So just remember that. And so now that you know how to use these things, we're just going to go ahead and run a bunch of examples.